Hey guys, welcome to Math 1. As you can see today, we're going to be doing notes for section 2.5. We are going to learn a new way to write a linear equation given some information about the line. All right, we're also going to talk about vertical and horizontal lines, it looks like. How about that? So I actually started out with some examples here of something you already know how to do, so that we can compare what we're doing today to what we already know how to do. Plus, we get a little practice on this, and we probably never hurts to have a little practice. So the example says that we want to find the equation in slope-intercept form for each line. So the first one, if I want to find the equation, let's see, it goes through the point -2, 7, and 6, 11. The first thing I would want to do is find the slope, right? The slope would be y minus y over x minus x. This would be -4 over -8. And of course, -4 over -8 reduces to +1/2. And I have found the slope. So, got that part done. Now I need to find the y-intercept. To find the y-intercept, of course, I would use y equals mx plus b. And I would say, let's see, I'm going to use this point right here. What the heck? And I would say 7 equals 1/2 times -2 plus b. And I would multiply the 1/2 times the -2 and get -1. And I would add 1 to both sides. And I would get b equals 8. So, I now know what the slope is. I now know what the y-intercept is. And I can write my equation, y equals 1/2 x plus 8. All right? That is something you already know how to do. Let's look at an interesting example doing the same thing. In this case, again, I want to take my 2 points first and find the slope. It would be y minus y over x minus x, 3 minus -1. That gives me 0 over 4. And 0 divided by 4 is 0. The slope of this line is 0. Do you know what kind of line has a slope of 0? I'll bet you do. All right, so now I need to find the y-intercept. I could find the y-intercept by taking my point. I'll take this one. And I'll go y equals m times x plus b. And I will solve for b first by multiplying 0 times 3, which is 0. And I could subtract 0 from each side, but I think we don't need to do that. We know that it just cancels out. And I get b equals 8. Oops. I now know my y-intercept, and I know my slope. My equation would be y equals 0x plus 8. But you guys, being the fine Math 1 students that you are, we did not want to write 0 times x, because 0 times x is just 0. So really that kind of just cancels out the x. And I get y equals 8. This is a horizontal line. And anytime you have a horizontal line, your equation is not going to have an x in it. Because it's a horizontal line, it has a slope of 0. And the 0 just cancels out the x. So I get y equals 8. Let's go to the last example. In the last example, again, I need to find the slope. So my slope would be 2 minus 9, that'd be my y minus my y, over x minus x. And this time I get -7 over 0. Well, -7 over 0 is not actually 0, as many people think. negative 7 over 0 is actually undefined. See if I can fit that whole word in. Undefined. So this is an issue. You know, I got to point out, anytime you divide by 0, it is undefined in math. When you divide by 0 mathematically, the answer is undefined. So you can't put 0 and you can't put there is no answer. It literally is the word undefined. So if the slope is undefined, by the way, if you do that on your calculator, it will say error, because you can't divide by 0 in math. If the slope is undefined, how in the world am I going to write an equation for this line? All right? I can't write, you know, I can't find the y-intercept by saying 2 equals undefined times 5 plus b. What in the world? Can't do that. So I'm kind of stuck for a moment. But let's talk about what really happens here then. So this is the one exception to y equals mx plus b. There's, you know, all lines can be converted into y equals mx plus b equation except this one. It's the one exception. And it is a vertical line. A vertical line is the only type of line that you cannot write the equation for it in slope-intercept form. And I'm going to do an example here. So let's look at this vertical line. Let's put it right here. And I'm going to pick a couple points on this line like those. And we're going to look at them. All right, so from this graph, what is the slope of that line? You know, I picked a couple points on the line. I picked the points, let's see, 2, 1 and 2, 3. And when I go to calculate the slope, I get y minus y over x minus x. I get negative 2 over 0. And once again, I'm dividing by 0. So that is undefined. Slope's undefined. What is the y-intercept? Well, does this line cross the y-axis? It does not. And if a line does not cross the y-axis, then it does not have a y-intercept. It does not have one. So if the slope is undefined and it does not have a y-intercept, what is the equation for the line? Well, the equation for this line is actually x equals 2. And in fact, I would claim that all vertical lines have essentially the same equation. The equation mathematically is x equals h. And what we say is this h. H is the x value of every point on the line. H is the x value of every point on the line. For example, the x value of these two was both 2. On a vertical line, the x value is the same for every point on the line. So if you know the x value, then you can write the equation. It's just x equals whatever that is. Let's look at a couple other examples just for fun. So if I had this line, it would have the equation x equals negative 4. If I had this line, it would have the equation x equals 5. Here's the one that gets a lot of people, this crazy tricky line down the middle, sometimes called the y-axis. But the y-axis actually has an equation for it as well. The equation for that line would be x equals, I'll bet some of you know it, x equals 0. Because every point on the y-axis has an x value of 0. All right, so now you know how to write the equation for a vertical line. Here's the new thing for the day. We are going to write equations in what's called point-slope form. Point-slope form is just a different, different than slope-intercept form. It's a different way to write a linear equation. Now, to write an equation in slope-intercept form, you of course need to know two things about the line. All right? You need to know the slope, and you need to know the y-intercept. Hence the tricky name slope-intercept form. Well, if you're going to write an equation in point-slope form, then you also need to know two things about the line. You still need to know the slope and any, now I could say point here, but I like to say ordered pair. But an ordered pair is just a point. Any ordered pair on the line. And instead of using the slope and the y-intercept, you can use the slope and any ordered pair that's on the line. And right here is what point-slope form looks like. In this formula, the m is still the slope of the line. Now, here's where people get a little confused. The x1 and the y1, those are the two values that are any point. Right? The x and the y, these two actually are just variables that stay in the equation. Just like they stayed in the equation back here, right? When we wrote equations back here, we still had an x and a y in our final equation in slope-intercept form. Same deal. The x and the y stay in the equation. It's the x1 and the y1 that you're going to substitute numbers in for. Those are the two ones that represent an ordered pair that's on the line. Let's see some examples. It's really easy to do. All right, we are going to find the equation of a line that has a slope of 1/2 and passes through the point -2, 7. All right, so all we're going to do is we're going to start with our general equation, our general formula, y equals y minus y1. Oh my goodness, can't write and talk at the same time. Y minus y1 equals m times x minus x1. That is our general formula for point-slope form. And we're going to substitute these numbers in, right? So this is going to be my x1, this is going to be my y1, and this is going to be my slope. And I would get y minus 7 equals 1/2 times x minus -2. All right, so you want to make sure you put a -2 in. It's minus -2. And I could simplify that minus -2, right? That would actually be y minus 7 equals 1/2 times x, and minus a negative number is +2. And as you get used to this, you will never write minus negative. You'll just write +2, because when you subtract a negative, it's really plus, right? And you're done. I mean, this thing right here is point slope form. That's it. But I want to show you something interesting. Watch this. I could take this point slope form, as it says to do here, and convert it into slope intercept form. So let's do that right here. And I would convert this to slope intercept form by distributing the 1/2, giving me y minus 7 equals 1/2 x plus 1. Right? So distribute the 1/2. And then to get the y by itself, so that I'm in slope intercept form, I would add 7 to both sides, and I would get y equals 1/2 x plus 8. Now this equation is in slope intercept form. And I want to show you something. You see the slope I picked? And this point I picked? It's the same as we did right here. It's a slope of 1/2, and the point was -2,7. And look, y equals 1/2 x plus 8. Y equals 1/2 x plus 8. I got the same equation. All right, so that is point slope form. Point slope form. It's if you know a slope and a point, it's maybe easier to use than using slope intercept form sometimes. All right, let's try an example. Find the equation of the line that passes through 11,2 and 15,14. Even if I was going to use slope intercept form, the first thing I have to do, no matter which form I use, is find the slope. So let's find the slope. And the slope would be y minus y over x minus x. That would be -12 over -4, which is 3. The slope is 3. So let's go ahead and write that in point slope form. See, I don't have to find the y-intercept. I can go straight to my equation because I know a point and a slope. And my equation would be y minus the y value, 2, equals the slope times x minus the x value, 11. Boom! That's my equation in point slope form, and I'm done. Hey, just to prove something to you, look at this. I could have used this point, and I could have gone y minus the y value equals the slope times x minus the x value. Are these the same equation? Let's put them in slope intercept form and see if they're the same equation. Here I would distribute the 3 and get y minus 2 equals 3x minus 33. Then I would add 2 to both sides, and I'd have y equals 3x minus 31. How about in the second one? I would distribute the 3 and get y minus 14 equals 3x minus 45. Then I would add 14 to both sides and get y equals 3x minus 31. Look at that, they are the same equation. So my point is, it doesn't matter whether I write it using this point or whether I write the equation using this point. They're the same equation. And look how easy it was to write the first equation in point slope form. All right, one more thing and we're done. I'm sorry I went too long here today. I did. 20 minutes is too long. I was trying to keep it to 15. I want to put some equations up here real quick and see if you can tell me the slope, 2/3 times, we'll just do 2 of them. I don't need to do 3 of them. Get rid of that guy. Let's save a little time. Y plus 1 equals -7x minus 5. Okay, so the question is here, an equation is already written in point-slope form. Can you name the slope of the line and the point on the line that was used to write the equation? Can you do it? Think about it for a second. What's the slope of this line and what's my point I used? What's the slope of this line and what's the point I used? Well, the slope is easy, right? The slope is 2/3. It's right here. But what is the point that I used? Well, here's the x value and here's the y value. But the thing you got to pay attention to is the sign, right? So the x value was actually x minus x1, but this is plus 4, which means in my ordered pair, it must have been a x value of -4. And because it was -4, it turned to +4 because it was minus -4. The x value was -4. And the y value was +2. This was a +2 when I plugged it into the formula. Do you get that? And over here, the slope, of course, is -7. The x value is 5. And the y value was actually -1. You might think of that as just, it's the opposite of the sign in the formula. All right, that's it. Homework's on Delta Math. Good luck. I'll see you tomorrow.